Case is an API search engine supported by a crowdsourcing-based API search approach named CrowdAPS, which is proposed in our previous work. The critical idea of Case is to infer an API's topic and popularity by analyzing the semantics and the number of lists, including the API data account. Therefore, Case would provide semantics matched and popularity satisfied results for a given query. The figure shows the search interface, and 52 sample queries from 12 categories are offered here. Users can click any sample query or input a query manually for searching the appropriate APIs. Here we show the search result page while the sample query holiday is chosen. Each search result entity mainly includes 4 parts: API name, API description. The category API belongs to the list number including API, which shows API's popularity. The first icon beside the API name links to the API page in Programmable Web, which offers more detailed information about the API. When click the second icon, it will show the page of data lists, including the API, and can help user to better understand the crowdsourcing knowledge about API. In addition to the search page, we designed several pages to show some information and analysis about APIs, data lists, and our algorithm framework. That's all about our API search engine Case. We introduced a feature of Twitter card lists, which is used to help users organize the Twitter accounts they are interested in. Twitter lists include list names and descriptions that contain a lot of semantic information. The figure illustrates the contents of lists by showing several lists including LinkedIn. Most of the list names are related to social media and career, along with the corresponding descriptions, which distinctly reflect the topic of LinkedIn. The figure illustrates the whole algorithm framework. The list data is crawled from Twitter after being matched with APIs crawled from Programmable Web. Generally, the process of the algorithm could be divided into 2 parts. The first part is utilizing list information to compute semantic similarity between an API and a user query, which contains 3 steps: pre-processing, LSI, and similarity calculation. Another part is about popularity calculation for each API based on its list number. Finally, the scores obtained by the 2 parts are combined with a certain weight. Then a list of ranked results will be returned to the user. After the data pre-processing like tokenization, stop-words removal, stemming, the features extracted from lists and the given query could be mapped into a conceptual space through LSI. The returned relevant APIs are ranked according to cosine similarity, so the semantics-based rank score is defined as score S. Twitter lists of APIs imply popularity information. The intuition is that the more user-created lists including an API, the more popular this API is. Consider the large gap between the number of different APIs lists. We normalize the number of lists into 0 to 1 with its logarithmic form. The popularity-based rank score is defined as score P. The final rank score is decided by the integration of semantic similarity and the API's popularity, which is defined like this. Lambda is a weight to balance the importance of semantic similarity and popularity. To enrich the function of case, it is considered to assign tags for each API, which can be used to find APIs with a similar function, and to recommend APIs for a specific mashup in our feature work.